Okay, so how did you do? So how well did you do on the chapter 1 test? And how well did you do relative to your classmates? So if Mr. Picerni took a chapter 1 test, got a 75, we need to determine if this is good or bad and what the example would be. So what we said was it would be good when 75 is above the mean. It'd be bad when 75 is below the mean. So here is 20 data values from a random sample of the chapter 1 test. Not our data, but someone else's data, along with a dot plot and summary stats. So Daffy scored a 65. What is Daffy's percentile? So to find a percentile, you'd look at or below the 65. So there are 3 data points at or below. So we do 3 out of 20 and divide that. 0.15. So that means that Daffy's score is at the 15th percentile. And then was Daffy above or below the mean, and how many points? How many standard deviations? So was Daffy above or below the mean? Below. So right here is our mean, 80. So below the mean. So by how many points? So we just need to subtract them. Okay. 15 points. And then by how many standard deviations? For calculation's sake, assume that SD is 10. So see how SD on our summary stats is 10.011? We're going to just round that to 10, make it a little bit easier. So we want to find out how many standard deviations. So this is where we take the 15 that he was below and divide by 10. And that would come out to 1.5. So his score was 1.5 standard deviations from below the mean. So let's go ahead and write that. So you can't just say it was 1.5 standard deviations from the mean. You have to say above or below. Okay, Bug's score was 88. What is Bug's percentile? So we need to subtract. No, we need to find out how many are 88 or below. So where is the... I guess we could look here. Look at that. Look at the actual data. Because it's actually in order. So how many are at or below 88? 16, because there's 20 total, 4 above, so we could subtract that and get 16 out of the 20. And divide it, 0.8. So it was at 80th percentile. Okay, was Bugs above or below the mean? Above. And we need to find out how many points above the mean. So score of 88. So we'd have to subtract 88 minus 80. So 8 points above the mean. So even though we can do the 88 minus 80 in our head, you would want to write it out to show your work. So it says about how many standard deviations. So to find out standard deviations, we would take the difference and divide by the SD. So 8 divided by 10, 0.8. So that's how many standard deviations. So we need to write this in sentence form. So Bug's score 0.8 standard deviations above the mean. Okay, a z-score is defined as a number of standard deviations above or below the mean. So what we just found on Daffy and Bugs was our z-score. So the way we find z-score is we take the value, whatever data value they want us to find the SD or the z-score on, value minus the mean, and then divide by your standard deviation, SD. So we would do xi minus x bar over SD or sigma.
What is that at the bottom?
Sigma, which is our standard deviation symbol.
I thought SX was the standard deviation.
So I believe we need to change this because the sigma is for population and we're just taking a sample. So you're right. SX, yes, thank you. Okay, so Porky scored a 98 on the Chapter 1 test. Find with your formula and interpret the z-score. So z is found by doing the value. So our value is 98. Subtract our mean, 80, and divide by our standard deviation. So that would be like 18 over 10, which would be 1.8. And since it's positive, it's above the mean. If it was negative, we'd say below the mean. So we'll write this as, we have to find it, we found it, interpret. So Porky's score of 98 was 1.8 standard deviations above the mean. The mean of 80. Okay, go to the next page. So up at the top, we have 3 dot plots. So the first dot plot is our original, and it gives our summary stats there. So let's compare that to our dot plot B. So look at the shape. Is the shape the same or different from dot plot A to B? Same, so shape is the same. What about the x-axis? Look at the x-axis. It's different. So how could you change from our center being 80 to our center being 0?
Because that's how many standard deviations it is from the mean. So the mean would be 0 because it's 0, right?
Yes. So the mean would end up being 0. So what happened to every data point?
Subtracted by 8.
Exactly, yep. So every data point was subtracted by 80. And 80 is our mean. So the shape, nothing happened to the shape. It's the same shape. So we're going to put nothing here. The center is still in the center, but instead of being 80, it changed to 0. And then variability, look at your x-axis of the original. It was like 80, 85, 90, 95. Then look at dot plot B, 0, 5, 10. Is variability the same? Look at your x-axis. It's not the same numbers, but see how it changes, like the scale? It's still 5. So our variability, nothing happened to it. Okay, so now we're going to go from point B to point C. So what happened from plot B to plot C?
Oh, the X values changed.
Yeah, the x values changed again. So instead of it being 5, it's now at 0.5. Instead of it being at 10, it's at 1. So what happened to every value?
It was divided by the standard deviation.
Yeah, it was divided by the standard deviation. Every data point was divided by 10, which is our standard deviation. Okay, so now we got to answer the questions again. Shape. Yeah, shape still looks the exact same, so that's great. So nothing happened. Is the center still at 0? Yeah, so we're good there, so nothing. Variability would be our x-axis, like the scale. Was that changed? Yes. So it was changed to 1 by dividing by 10. Okay, so instead of being all the data points on a dot plot, it was changed so that the mean is 0, standard deviation is 1. And so this is how we standardize scores, which makes it where we can compare two things, two different data to each other. So it says, what is the mean standard deviation of the distribution of z-scores? Will this be true for any? What is the mean? The new mean? 0. What's the new standard deviation?
1.
Yeah, 1. And will this be true for any distribution? Yes. It will be true. No matter the shape. Okay, so here's our example. It says Daffy took an algebra test and got a 96%. The class average was 94 with an SD of 3. Bugs took an AP Calc test, got an 83. Class average was a 70 with an SD of 5. Daffy says that he did better than Bugs, but Bugs disagrees on who did better relative to their exam. So the way we can compare these is by using the z-score. So I want you to go ahead and do that. Go ahead and do that. So I just used the formula and went ahead and just wrote down what that would be with numbers plugged in. So now use your calculator, or simplify by hand. It's like 2/3, which is 0.67. And then bugs, 2.6. What is that it? Just 2.6? Is there any other number behind that? No. Okay, good. Okay, so if we were to have this on a curve where we have our z-scores, let's see where they would be. So bugs is 0.67. So this would be like right here. I mean Daffy. I don't know if I said bugs or not. Whoops. Bugs is 2.6. So it's like right here. So who did better, relatively speaking?
Bugs.
Yeah, bugs did better. So if this was like a problem on a test, you would write bugs did better, having a z-score of 2.6 compared to Daffy, which is only 0.67 standard deviations above the mean. This one doesn't ask us to write it in sentence form, so we're just going to leave it like that. All right, so let's review. Standardize the values. So z-scores are found by doing whatever your data value is, xi, minus x bar over standard deviation. So this is the value minus the mean over standard deviation. So once you find it and you're writing it in sentence, this is a sentence starter. So you would say whatever the context is. So like bug's score is, so whatever the context is blank standard deviation. So you want to put your z right there. Is 0.67 standard deviation. I guess it was Daffy was that. Standard deviations above the mean or below if it is negative. Above/below. All standardized deviations have a mean of 0 and a standard deviation of 1. That makes it easy to compare. So we use it to compare things from different data sets. Okay, given a distribution, let's talk about the effects whenever we're changing it from our data to the normalized data to the standardized data. If you add or subtract each value by some kind of constant a, kind of like we did minus 80, the shape and variability stayed the same. But the center was changed either by adding or subtract. Multiplying and dividing each value by a constant. So then whenever we went to the dot plot of C, we divided by the 10. And when we divided by the 10, the shape stayed the same. But the variability, it changed. Multiply or divided by that B. So in our case, it was dividing by 10. And so the variability changed, which made that x-axis change, which made our standard deviation 1 at that point. Okay, so the rest of the time, and for your homework, you're going to do this application problem.